space is cold. You already know that. The vacuum between stars sits at about -270 degrees Celsius, close to absolute zero, close to the coldest temperature the laws of physics allow. But 5,000 light-years from Earth, there is something colder. Not slightly colder, not a few degrees colder. This object clocks in at -272 degrees Celsius. 1 single degree away from the absolute coldest anything in the universe can ever be. And here's what makes that terrifying. Space itself isn't that cold. The Boomerang Nebula is colder than the background temperature of the universe. It is, as far as we know, the coldest natural place in existence. And it was created by a star dying in a way that shouldn't produce something like this. So why does it exist? And what does it tell us about the universe's rules? And what happens when something breaks them? In 1980, 2 astronomers, Keith Taylor and Mike Scarrett, pointed a telescope at a faint smudge of light in the southern constellation Centaurus. What they saw through the blur of ground-based optics looked like a lopsided bow tie, slightly asymmetrical, faintly glowing. They called it the Boomerang Nebula, after the curved shape they thought they saw. Years later, the Hubble Space Telescope got a proper look. What it revealed was spectacular. 2 enormous lobes of gas and dust expanding outward from a dying star at the center. Pale blue, almost ghostly, a perfect eerie hourglass frozen in deep space. But the real discovery wasn't visual, it was thermal. When astronomers measured the temperature of the gas cloud surrounding this nebula, they got a number that stopped them cold. No pun intended. -272 degrees Celsius. To understand why that number is so strange, you need to understand one thing about the universe. The universe has a background temperature. When the Big Bang occurred 13.8 billion years ago, it released an almost unimaginable amount of energy. That energy has been spreading, thinning, and cooling ever since. Today, what remains of that primordial heat is a faint, uniform radiation that permeates every corner of existence. It is called the cosmic microwave background, and it sets the temperature of empty space at roughly -270.45 degrees Celsius. Nothing in nature, no nebula, no gas cloud, no region of empty void, should ever be colder than that. The CMB is the universe's baseline, its floor, its thermal minimum. The Boomerang Nebula is colder. At -272 degrees Celsius, it sits below that floor, below the temperature of empty space. In a universe where the background radiation heats everything to a minimum level, this object has somehow slipped beneath it. How? The answer lies in what's happening at its center. At the heart of the Boomerang Nebula is a star in the process of dying. Not a dramatic supernova death, not a collapse into a black hole. This is something quieter, more prolonged. The star is what astronomers call an AGB star, an asymptotic giant branch star, an aging red giant that has burned through most of its fuel and is now shedding its outer layers into space. But this star isn't shedding slowly. It is ejecting mass at a rate of roughly 1,000th of a solar mass per year, and it is doing so at nearly 164 kilometers per second. That's nearly 590,000 kilometers per hour, faster than almost any other outflow ever recorded from a star like this. Here is where the physics gets extraordinary. When a gas expands rapidly, when it's forced outward at high velocity, it cools. This is the same principle behind your refrigerator, behind an aerosol can feeling cold when you spray it. Rapid expansion equals rapid cooling. The Boomerang Nebula's outflow is so fast and has been ongoing for so long, approximately 1,500 years, that the gas has cooled well past the temperature of the CMB. It has, in effect, refrigerated itself below the baseline of the universe. Nature built a freezer in space by accident. Here's where the story gets stranger. For years, scientists believed the Boomerang Nebula was a perfectly bipolar nebula, two symmetrical lobes expanding in opposite directions. That's what Hubble showed. Clean, geometric, almost beautiful. But in 2013, a radio telescope array called ALMA, the Atacama Large Millimeter Array in Chile, looked at the same nebula using a completely different method. What it found didn't match. The optical images from Hubble showed the glowing gas lobes. But ALMA was detecting something colder, something much larger. An outer shell of gas, invisible to optical telescopes, surrounding the entire structure. Irregular, asymmetric, cold. The bow tie shape that gave the nebula its name may not reflect the full picture. The real structure appears to be more like a sphere with a pinched waist, a dying star surrounded by a vast invisible envelope of ultra-cold gas with the bright optical lobes punching through it. The bow tie we see is just the part that glows. Most of the nebula is too cold to see with visible light. Most of it is hidden in the dark. The Boomerang Nebula is a temporary anomaly. That matters, because the universe doesn't like anomalies. The CMB is constantly bathing this nebula in radiation. Slowly, over thousands of years, the gas will absorb that radiation and warm up. The nebula will eventually reach equilibrium with the rest of the universe. It is, right now, in a brief window, cosmically speaking, where it exists as something impossible, something colder than the void, and once it warms, it will become just another planetary nebula, another faint smudge in the catalog, another marker of a star that died. But right now, it is a record holder. Right now, it is colder than empty space. And it raises a question that astronomers don't have a clean answer to yet. If one dying star, under the right conditions, can drop the temperature of its surroundings below the universe's own baseline, what else is out there that we haven't found yet? What other rules is the universe quietly breaking, in places we haven't thought to look? The universe is not a neat place. It has floors and things that fall below them. It has rules and objects that exist in defiance of them. The Boomerang Nebula is just one example. A dying star, a fast wind, 1,500 years. And somehow, nature produced the coldest place that exists. If you found this extraordinary, you know what to do.